Hello, pre-calc students. Right now I'm going over finding the exact value of tangent of 13 pi over 4. So first I need to find an angle coterminal with tangent of 13 pi over 4. To find an angle that is coterminal, I must add or subtract 2 pi, because I'm trying to find an angle that is within 2 pi radians of 13 pi over 4, so it'll land on the same terminal side. So given that, I will have 13 pi over 4 minus 2 pi, which is equivalent, because I need to subtract with a common fraction. This is equal to 13 pi over 4 minus 8 pi over 4, which is equal to 5 pi over 4. And 5 pi over 4 is in quadrant 3 of the unit circle. This is 5 pi over 4 radians right here. That is a 5 pi over 4 radian angle. And because of that, that is 5 pi over 4 radians. At this point from the unit circle, if you don't know, the tangent, the sign here, the coordinates of this point are negative root 2 over 2 and negative root 2 over 2. And this is the x coordinate is the equivalent to the cosine of theta, and the y coordinate is equivalent to the sine of theta. So the tangent of this angle, the tangent of, which is equivalent to the tangent of 5 pi over 4, either you have it memorized as 1, which is the answer, or you see it as, you can find the sine of 5 pi over 4 over the cosine of 5 pi over 4, which is negative root 2 over 2 divided by negative root 2 over 2, which is equal to positive 1. Also, you can just take your calculator on mode radian, find the tangent of 13 pi over 4. That's equal to 1, and so then your answer choice is 1. Alright? I'm actually just going to make a video going straight through for this sheet of paper, so let's show all the work here. One note that I have for the inverse cotangent is that the cotangent, just in general, this is a rule, the cotangent of theta is a reciprocal relation to tangent. So this is equal to 1 over the tangent of theta. So regarding the inverse cotangent, okay? The inverse cotangent of a value is equal to the inverse tangent of 1 over that value. Just a second. I'm going to be right back. Door. My apologies. But anyway, what we need to, another thing we need to establish, and this is just from your trig values, so this is from your trig sheet where you need to memorize your trig values. Is that the cotangent of 30 degrees is equal to the square root of 3, which means that the inverse cotangent of the square root of 3 is equal to 30 degrees. One note that you have to memorize or just understand is that with inverses, the inputs and the outputs switch. So all that being said, if the inverse cotangent of the square root of 3 is 30 degrees, then the cosine of the inverse cotangent of square root of 3 means that this is equal to the cosine of 30 degrees. The cosine of 30 degrees is equal to root 3 over 2. This is our solution. If we are evaluating this in our calculator, to evaluate inverse cotangent of x, we're going to have to, in your calculator, write the inverse tangent of 1 over x. So we're going to have to, with our calculator, oh, my calculator went away. Alright, I need to find the cosine. Now the inverse cotangent of the square root of 3, I need to rewrite as the inverse tangent of 1 over the square root of 3. Oh. Oh. Of, they create a parentheses, 1 divided by the square root of 3. That's 0.866, which is equivalent to the square root 3 over 2. Okay? So our answer here is root 3 over 2. Find the period, amplitude, and phase shift of 3 times the sine of 3x minus 4 plus 8. So here we have to factor out 3. This will become 3 times sine. You always factor out the coefficient of x. 3x divided by 3 is x minus 4/3. Negative 4 divided by 3 is negative 4/3. Plus 8. Now 3 is the amplitude. So the amplitude is 3. Three is the period. So B, well, 3 is equal to B. Okay, so 3 is B. And the period is always going to be 2 pi over B. So that's going to be equal to 2 pi over 3. So that means this is equal to the period, 2 pi over B, 2 pi over 3. And that is minus 4/3, so that's going to be a shift right 4/3. And then that shift 8 plus 8, it's going to be a shift up 8. And we weren't even asked to find the vertical shift, but the amplitude is 3, period is 2 pi over 3, phase shift is right 4/3. Alright, person A is in a window that is 200 feet away from a flagpole. Alright, and this is the flagpole. 200 feet. The angle of elevation to the top of the flagpole is 40 degrees. This is 40 degrees. The angle of depression to the bottom of the flagpole is 50 degrees. This value is 50 degrees. And this length right here, this length is 200 feet. How high is the flagpole? So, here's what I have to do. This is going to be relative to 40 and 50. The red line is the adjacent side. And then the height from the window to the bottom, this is going to be the opposite side for triangle 1. This will be the opposite side for triangle 2. And we have to add these two values up. So we need to know that the tangent of 40, alright, I'll call opposite, I'll just call this x1 and this length x2. The tangent of 40 is going to be equal to opposite over adjacent, so SOHCAHTOA, x1 over 200. So x1 is equal to 200 times the tangent of 40 degrees. By the same logic, the tangent of 50 is going to be equal to x2 over 200. So x2 is equal to 200 times the tangent of 50 degrees. So the height of the flagpole is x1 plus x2. That's the height. So on my in the calculator, oh, where'd my calculator go? Okay, sorry about that. So you need to find in degree mode. $200 times the tangent of 50 plus 200 times the tangent of 40. And this will indicate that a height of the flagpole is 406.17 feet. The height of the flagpole is 406.17 feet. All right. Data below, tables below, shows the population of rabbit population on the farm. Which statement is true about the data? So first we have to enter this data into our calculator. Stat, edit. L1 is 0, 1, 2, 3, 4, 5, 6, 7. L2 is 6, 9, 14, 22, 35, 53, 79, 118. All right, now we need to look at the data. Second, stat plot. Plot 1 on. Zoom 9. Look at this data. This beta looks like it's exponential. That's the shape of the exponential, so it's going to eliminate answer choices A and B. So let's look at this exponential equation. Stat, calc. You need to do an exponential regression. All right. So for our exponential regression with a times b to the x, our formula is approximately 5.99 times 1.53 to the x. 5.99 times 1.53 to the x. And that 0.53, that's the growth factor that indicates that we're growing exponentially by about 54% each year. So that 0.53, that matches up to that exponential growth, 0.53 with about 54% growth each year. So the answer choice here would be D. What is the distance between 0.1 and 0.2? And sorry, let me change this. That's a 40 degrees, okay? So to find the distance between 0.1 and 0.2, we first need to find the height of this opposite side. The height of this opposite side, well, the sine of 50 let's call this x1. The sine of 50 degrees is the opposite over the hypotenuse, so that's going to be equal to x1 over 45. So x1 is equal to 45 times the sine of 50. So I can do in degree mode 45 times the sine of 50 degrees. So it's equal to 34.47. So this x1 is equal to 34.47. And then from this point, I can just find, using the tangent, the distance between 1 and the middle point and 2 and the middle point. So now I can say the tangent of 50 is equal to the opposite, which is 34.47, over the adjacent, which we're going to call x2. So x2 times the tangent of 50 is equal to 34.47, and so that means x2 is equal to 34.47 over the tangent of 50. And by the same logic, if we call this length x2, x3 is going to be equal to 34.47 over the tangent of 50. So by the same logic that we found x2, we can also find x3. This distance between 1 and 2, that's x2 plus x3. That's the distance between 1 and 2. So just need to find in the calculator 34.47 divided by the tangent of 50. Oh, and sorry, right here, this angle is 40, so that would be the tangent of 40 divided by the tangent of 50, and then we add to that 34.47 divided by the tangent of 40. So that's going to be equal to the total length in between 0.1 and 0.2 is going to be 70 point. That's approximately going to be equal to 70. So x1 plus x2, that is going to be equal to 70. All right, that is our video.